So let's all mute ourselves. So we are going to do implicit functions, implicit differentiation, implicit differentiation. That's what we are going to do. Now, under the implicit differentiation, unlike the normal differentiation where we differentiate everything with respect to x, here we are going to consider differentiation both x and y values. But we are going to still use the same principles, the product rule, the chain rule, the all the rules we've learned, the quotient rule, and so on and so forth. We are going to use everything here. But in this case, we are going to differentiate both the x and the y. I'm going to teach you how we differentiate y too. Then we use the same procedure, just that there's a little difference. There's a little difference. So for instance, if it was to be x, for instance, if I have y is equal to x, maybe x squared, so is equal to x, okay, is equal to maybe x, maybe x squared. Then we are asked to differentiate. Then they say find dy dx. Then that means y is equal to this. So we are going to differentiate with respect to what? We are going to differentiate with respect to x. So if y is equal to the whole of this, then that means differentiate the whole of the respect to x. So now our y will now become 2x, just as we already know, 2x. That's what we studied at first. Now, there are some functions that may not be given directly or explicitly. So for instance, if you are given x squared y minus 3x is equal to 2, or we are given y raised to the power 4 is equal to 5x squared y, then that means, initially we were just given y is equal to a certain variable. Y is equal to a certain variable where we know that that variable should be x or should have x in it. Now, for instance, if you are given y raised to the power 4, y raised to the power 4 is equal to maybe 2x raised to the power 3. 2x raised to the power 3. So when I give me something like this, then that means there's something wrong with the y. We also have to differentiate the y. We also have to differentiate this thing. Then now the question says that find dy all over dx. So if you have to find dy all over dx, then that means the question didn't say we should find for y raised to the power 4. The question says we should find for dy dx. So that means we are supposed to get a dy dx in this thing, in this question we've been given. Now, when we are differentiating y with respect to x, we know that because just y, if you are differentiating y with respect to x, then that means finding differential of y will give us is the same as dy all over dx. Dy all over dx. So differentiating y with respect to x is dy all over dx. And dx is down because there's no x in this thing. So as a result, we are going to get dy all over dx. This showing that or implying that we are differentiating y with respect to x. So that's that. So if you are given y raised to the power raised to the power 2, then we've been asked to find for we've been asked to differentiate the y raised to dx. Then this means that raised to the power 2, if you are to use the normal rule, then we are going to get 2y. If you get 2y, then that means you'll be left with another y. So then we are going to get the y all over dx. So y raised to the power 2, differentiating y raised to the power 2, we are going to get 2y. The 2y is the 2 times the y, dy dx. Are we getting it? So this is how, when we are to differentiate y, that's how it's going to be. So if y is equal to dy all over dx, then that means y squared will be equal to 2 come and multiply the y, then we are going to get 2y dy dx. That means we are still differentiating this with respect to x, but there's no x in it. So then that means we conclude that there should be a certain dy all over dx. That shows that we are still differentiating this thing. So if you are asked to differentiate y raised to the power 4, y raised to the power 4, y raised to the power 4, then we are going to get, this will be 4 times y. So we are going to get 4y dy dx. Dy dx. If it is y raised to the power 3, then we are going to get 3y dy dx. But don't forget that this will be raised to the power 3. We use our normal rule. So this is the power 3 dy dx. I hope you are getting it.
Yes.
Are we getting it? So that's how it's going to be. And so we just use the normal x differential, but we add the dy dx. Are we getting it? Because this, we are differentiating the whole of with respect to x, but there's no x in it. That's why we still keep. So we are doing it dy dx just to show that we are differentiating this with respect to x, but there's no x in it. So we have to maintain this so that the person will know that, oh, so that mathematically we know that we are differentiating with respect to x. For instance, if we have x, y, and we've been asked to differentiate, we've been asked to find for dy dx, then that means because there's x here, when you differentiate only x, what are we getting? 1. Do we know that? But you bear with me that this and this are multiplying. So in this case, we are going to use the product rule. So when we are using the product rule, x will stand for u, this will stand for v. Are we there?
Yes.
So, yes. So if we are using the product rule, x will stand for u, y will stand for v. And so using the product rule is u div plus v du. If I'm right, yes. And so if this is standing for u and this is standing for v, then that means when we are to differentiate this with respect to x, we are going to get y plus, if you are to differentiate this, the whole of this, then what are you going to get? So this one will be 1 times y plus this one will be d x dy dx. Do you get it? Do you get it?
No, sir, please go over again.
Let me go over again. So for instance, you've been given this work. You've been given x, y. Then the question says that maybe dy dx is equal to then or y is equal to xy or something. You've been asked to find for dy dx. And so if you are asked to find for dy dx, then just like when we are doing only x values, you are going to this in dy dx. So this is what we are finding. But you bear with me that x and y, they are product. X times y, that's what it means. I hope we get it to that point.
Yes.
And so that means, and anytime you get product, then that means because there are 2 variables, then we use the product rule. And the product rule states that dy dx, dy div plus v du. I hope this is the product rule.
Yes, sir.
So looking at this two, then we can say that let x be equal to our u and y be equal to our v, right?
Yes.
So the first one is what we are going to do. What we are going to first do is we are going to keep so we are going to differentiate v. So we are going to keep u, then we differentiate v. Are you getting it?
Yes, sir.
And so when we keep u is x. When we differentiate v is what? Y. But y, we found that y, when we are differentiating y is equal to dy all over dx. When we are differentiating y with respect to x, then that means we are going to get dy dx. Are we getting it?
Yes, sir.
So we are going to get dy dx plus, then we come and keep v. V is what? Y.
Yeah.
Then we come and differentiate what? X, which is u. So when we differentiate x, what are we getting? 1. So this will be y times 1, which is y. Are you getting it here?
Yes, sir.
So now when we get to this way, then we would have to find for dy dx. The question says that find dy dx. So we can simply just equate this one to 0. You can simply just equate this one to 0. Now when we equate this one to 0, because we are looking for dy dx, what we are going to do is y will come here, or
No.
so then we can confidently say that x dy dx is equal to what? Y, or it's equal to minus y. So when it is equal to minus y, then we can find for, we are looking for dy dx. So we divide here by x, then we divide here by x. And so we are going to get dy, we are going to get dy dx is equal to minus y all over x. Are we there?
Yes, sir.
I hope you are getting it.
Yes.
Those who are copying, you can copy so that we continue. So that is what we are going to do. So when we, anytime we get two distinct variables, separate variables, x and y, that's what we are going to do. So copy it. Let me check my soup. Can't you guys sense or smell the scent of my soup? So that is it. And I've explained why y is equal to the y all over dx. I know I've explained it. I'm cleaning it. So implicit differentiation, we are continuing. So just as we said, so I told you that y, the differential of y is equal to dy dx. That we already know. Dy dx. The differential of y is equal to dy dx. That means hence the differential of y squared. Y squared is equal to what? Y 2y. We are going to use the same principle. 2y dy dx. Are we getting it?
Yes, sir.
So that is it. Now when we go to the other differentials like dy squared dx, we are going to learn how it works. We are going to learn how that one to work. So for instance, maybe when you are given y raised to the power y cube, you know how it's going to be. So it's going to be 3y squared dy dx. We still add the dy dx, so because we are differentiating with respect to x. Are you getting it?
Yes, sir.
So now, if it was to be, let me just explain one or two things so that you get it well. It was to be something like this, maybe y, maybe x, xy. Then they are asked to find for the x, find the x dy. If it is find the x dy, then that means we are differentiating x with respect to y. Then in that case, you won't repeat it. That means y will go to 1. Are you getting it? That means you are differentiating any y in it. And this means the x here means that we are differentiating the whole of this with respect to x. But there's no x in this. That's why we keep the x there. But for instance, if it was x with respect to y, then that means we can do away with, after differentiating, we can do away with this one. So in this case, it would have been something like this. Maybe x, if when is it, x is equal to y raised to the power 2. Maybe y raised to the power 6. Then they say that find the x dy. Find the x dy. Then that means the reason one is find the x dy is that we assume that x is standing for the whole of this. And we've been asked to differentiate anything in this, the whole of this one. Anything in the whole of this one. And the whole of this one is y, or constitute y. So then that means you are differentiating the whole of it with respect to y. And so if you are differentiating with respect to y, then that means that dx dy will become, this one become 5 what? 5y raised to the power, 6y. 6y raised to the power 5. Are we getting it?
Yes.
Yes,
So that is the only thing I wanted to explain. That is why normally when we are differentiating respect to x and there's x in it, we don't add the dy dx and so on and so forth. I was just trying to explain it. So y is equal to differentiating y respect to x is dy dx. Y squared will give us 2y dy dx. So I hope you are getting it. Now when we have product, we are going to use the product rule. When we have divisions, we are going to use a quotient rule. I hope you are getting it now. So
yes.
so given that, let's try this. Given that y raised to the power 3, y raised to the power 3 minus 2 minus 2y raised to the power 2 plus x raised to the power 2 is equal to 4. Then the question says that find dy dx. So the question is saying that we should find dy what? Dy, we are working it together or we are learning together. So find dy dx. And so then what we are going to do is, this is y raised to the power 3 minus 2y raised to the power 2 plus x raised to the power 2 is equal to 4. So we are going to differentiate the whole of this with respect to x. So now we first differentiate this with respect to x. So when we differentiate this with respect to, what are we going to get? We are learning together. Maureen, what are we going to get?
So you get 3y squared
3y squared.
exponent to dy dx.
I'm coming. Dy dx.
Yes.
Dy dx. Asha, what are you going to get? The 2y what minus? Asha, what are you going to get?
Minus 4y dy dx.
Minus 4y. Minus 4y dy dx. Daniela, what are you going to get?
2x.
2x. 2x is equal to, what are you going to get again? Daniela, continue.
For 0.
0. Correct. Then now the question says you should find for what? Dy dx. And so where do we have dy dx? We have dy dx here. We have dy dx here. So Hannah, what are you going to do now? Hannah, I'm listening to you. Ruben, what are you going to do now? Ruben, what are you going to do now?
Say, I don't understand anything.
We're enjoying. We had already started. Sorry. Maureen, what are you going to do?
So please, you group like them. So
We are going to group like them. So we are going to get. We are going to get 3 I want to free what? Free y raised to the power 2, right? Raised to the
Yes.
power 2. Raised to the power 2. dy dx minus 4y dy dx. Then we will take the negative, the 2 to the other side, right?
Yes.
Minus 2. Minus 2x. Now when we get here, then we are going to factor some out. Or we are going to do some factorization. What are you going to factor out? We are going to factor dy dx out. So we can factor dy dx out. Dy dx out. Into brackets. When we factor it out, what are we going to get? Free y. We are going to get free y raised to the power 2. Free y raised to the power 2 minus 4y minus 4y is equal to minus 2x. So we want to find for dy dx. So we will let dy dx stand on its own. So then we are going to get dy is equal to minus 2x all over into bracket 3y minus 4y. Are we there?
Yes,
So this
sir.
will be our final answer. This will be our final answer. I hope you get it now.
Yes, sir.
So this will be our final answer. This will be our final answer. Okay, let's do this one. Let's try our hands on this. 2x squared. Right, 2x squared. Find dy dx. Okay, so find 2x squared. 2x squared minus y raised to the power 4. Daniela, mute your distance. I raise the power 4. Is equal to 4x. Find it. Do this one for me. Find dy dx. Do this one for me. Who is done?
Sir, please, I'm done.
What do you get?
4x minus 4 all over 4y cube.
So simplify. You can do something about it. It's quite, but I can do something.
Sir.
Yes, sir. You say x all over y cube minus 1 all over y cube.
That is very long. Look at it.
Sir,
Yes.
x minus 1 all over y cube.
Exactly. Who else? Daniela. Danny baby.
Yes, sir.
What did you get?
Yes.
What do you get?
That x minus 1 all over y cube.
Okay. Harriet, what did you get? Harriet.
I'm not yet done.
Okay. Lydia, what did you get? Lydia, what did you get? Lydia, what did you get? For the next thing, we will start again. On the goals of you start again. So we are doing only implicit. I want us to understand it better. Unless we are done with our question solving. So let's do it. Those of us who don't understand, let's do it. So we are going to differentiate 2x squared with respect to x. And so we are going to get 4, help me, 4x minus 4y dy dx. Hey, 4y cube 4y cube dy dx is equal to 4. Then we are going to differentiate. Hey, we are going to, what do you call it? What am I even saying? We are going to group like terms,
Yeah.
Oh,
No, make dy dx the subject.
when we get here, dy dx is only in this one. Oh, I'm lying. It's only in this one. So we are just going to group like terms. So we just have to bring this one here and bring this one here.
Yes.
So 4x, we are going to get 4x minus 1.
Say
4.
minus
4 is equal to 3y 4y 4y dy dx. That's from the 34. 4y dy dx. Oh, dy dx. I hope I'm right. So then we are going to get, you let dy stand on it. We are going to get dy dx. Dy dx is equal to 4. 4. This we can factor. So 4 into bracket x minus 1 slash 4y cube. Or you can 4 into bracket y cube. So 4 will divide 4. So I'm going to get dy 4 will cancel. So we are going to get into bracket y raised to the power 3. I hope you are okay. Are you fine?
yes.
Okay, do this one for me. Find dy dx. Find dy dx. If 6y minus, find dy dx. Find dy dx. If 6y minus 3x4. If 6y minus 3x raised to the power 4 is equal to 2y raised to the power 6. Find dy dx if 6y minus 3x raised to the power 4. F 6y minus 3x x raised to the power 4 is equal to 2y raised to the power 6. Is equal to 2y raised to the power 6. So find dy dx if 6y minus 3x raised to the power 4 is equal to 2y raised to the power 6.
So this is the question again.
I said find dy dx if 6y minus 3x raised to the power 4 is equal to 2y raised to the power 6. Are we there? Are you all there?
Yes, sir.
So do it for me. When I listen, cats, you humbly listen.
Sir,
Yes.
is the answer 12x cubed minus divided by 6 minus 12y 5 exponent 5?
Come again. 12x cubed minus 8 divided by
No, divided by 6 minus 12y exponent 5.
6 minus 12y exponent 5. Please do some check your facts again. Check your facts again.
Sir,
Maybe
please,
Okay.
would you get,
you have to do some factorization and check. So check for me.
Okay.
sir, please,
Okay, Maureen, talk to me.
please, I had 2x cubed all over 1 minus 2y exponent 5.
Correct. Who else? Benedicta, what did you get? So Hannah, please check the distance and check the factorization and get back to me.
That
Bene baby, please, what do you get?
please, I'm still on it.
Okay. One next thing it will cut. Not this in a very soon. So when it cuts, you will join again.